So the next and last talk of this session in awardee I'd like to introduce right now, and that's Dr. Parvathy Prem for the Susan Mahan Niebur Award, the second awardee. Parvathy has done a lot of things in her still relatively short career. First of all, as you all know, she served as the SOC co-chair this year, and I'll be mentioning her contributions when I do thank yous later. But she really, she and Carolyn both really, I think, rewrote the rule book on how great SOC chairs can be. She's a science team member of NASA's LRO mission and SEAL payload. She's co-investigator on 2 SSERVI teams, both LEADER and ICE-5O. And her research focuses on applying computational methods to study solar system bodies and their interactions with the space environment. Her current investigations include modeling the origin and transport of volatiles on the moon, and developing radiative transfer models to aid in the interpretation of remote sensing data at radar, IR, and optical wavelengths. Her modeling is helping us gain a better understanding of how comet impacts on the moon could have delivered water and other volatiles to cold, permanently shadowed craters near the lunar poles. And she also serves as the lead of the Friends of Lunar Volatiles focus group for SSERVI, which is one of our very active focus groups. And on a personal note, we had a chance to get to know Parvathy well when she was spending a lot of time at SSERVI Central. She was still working at APL, but she was doing this when her husband was at Google. So, and then lastly, I really want to mention her efforts in equity, diversity, and inclusion. She is really a community leader in that, and this is something that I personally and a lot of us really appreciate. So, Parvathy, please take it away. Congratulations.
Thanks so much, Greg. All right. Well, good afternoon, good morning, good evening, everyone. It really means more than I can adequately express how much it means to win an award like this. It's an honor to share the limelight with Shuai, who is one of the finest scientists I know. I have an amazing mission concept, which involves sending Shuai to the South Pole to just wander around with a spectrometer. Definitely category 1, Paul. It's also a tremendous honor to receive an award that's named after Dr. Susan Mahan Niebur. I never had the pleasure of meeting Dr. Niebur in person, but I do know that she was an incredible person and that she is much missed. When I first read the words of Susan's that are on this slide, I was so struck by just how precisely someone else could express what it is that I wanted to be in my professional life. And one of my main motivations for writing a dissertation was so that I could start it with these words of hers, that all that survives after our death are publications and people. So look carefully after the words you write, the thoughts and publications you create, and how you love others, for these are the only things that will remain. It's been a tougher year than most for most of us, and I know enough of you well enough to know that many of the best people that I know sometimes feel rather inadequate. And I think the power of Susan's words is that they remind us of what's really important, which is that there are times when people, including yourself, will try to measure your worth by metrics that don't matter. The only thing that matters is that we do our work with integrity and that we take care of the people around us. And as long as we do those things, it will always be enough, and none of us will ever be inadequate. I wanted to spend a slide talking about some of my many people. I had the incredible privilege of being able to open up the participants list, go down and tell each of you how you've influenced my life. But in the interest of time, I'm not going to do that. Wouldn't look good as SOD chair and everything. In the center there are my parents and my tiny little brother. On the right is my favorite and only husband with one of our cats. They are the center of my universe, and I wouldn't be anywhere without them. I would not have got my PhD if I hadn't had the best advisors that I think anyone could have had. Philip Varghese is the taller gentleman, and Dr. David Goldstein is on the other side of me in that photo. Not in this photo is Dr. Larry Trapton, who was my third excellent advisor. Grad school was incredibly tough on me, and I wanted to quit several times. The only person who told me in no uncertain terms not to quit was David Goldstein. And I'm so glad I listened to him. And, you know, words fail me when it comes to thanking David, so I'm not going to try. I didn't get most of the postdoc positions that I applied to. In fact, I only got one, and that turned out, again, to be the best that anyone could possibly have had. Ben Greenhagen, Dana Hurley, and Wes Patterson gave me a chance that I didn't think I'd get. They hired me to work in the Planetary Exploration Group at APL, which consists of the best colleagues that anyone could possibly have. They are exceptional scientists, and they are incredible people. And APL is an institution that really and truly values its people and acts out that belief. I could give a whole other talk about SSERVI, which has been a fixture in my life since I attended my first Lunar Science Forum in 2011. But the only thing I will say is this, that it is not a small thing. And I say this to Yvonne and Greg and all the rest of the team. It is not a small thing to have built an institution that contains just so much warmth that I think all of us who come into contact with SSERVI come out of it being kinder people and better scientists. And what a great thing that is. LRO launched about a year before I started my PhD. I never in my wildest dreams thought that I would get to be part of the LRO team. And as far as I'm concerned, this will always be the most incredible mission to go anywhere in the solar system. So much thanks to John and Noah and all the rest of that incredibly large and incredibly awesome team. Lunar volatiles are the lens through which I got to know the moon and the rest of the solar system. And so I wanted to spend the next few slides giving you a big picture overview of lunar volatiles. The story of volatiles is really the story of the moon itself and of the Earth-Moon system. We know that volatiles were present in some shape or form when the moon formed around 4.5 billion years ago, and the nature of that primordial water and other volatiles remains the subject of ongoing, interesting, very active research. Over the next few billions of years, when the oceans formed on Earth and life began to take hold in those oceans, the moon and its neighbor, our own planet, were bombarded by asteroids and comets, some of which delivered volatiles to the surface. Between around 3.8 to 1 billion years ago, Mare volcanism set the lunar surface all aglow. Those eruptions carried water and other volatiles from the interior to the surface. And I think one of the most exciting mysteries that we will likely learn more about in the years to come is what happened to those volatiles and what traces of them remain behind. And even today, by the time we get to the dinosaurs and all the way to today, the lunar surface appears to be relatively quiet, but the volatile cycle is dynamic and it's constantly active. Micrometeoroid impacts send little bursts of water vapor into the exosphere where we can sniff them with our mass spectrometers. And then there's that incredible magic that takes place with solar wind bombardment. It never ceases to amaze me that sunshine falling on rock can create H2O. It's magic as much as it is chemistry. Around 1 or 2 weeks into my PhD, I was seriously worried that all the science seemed to have been done. I'd been reading a whole lot of papers, and I was worried that there wasn't really anything left for me to do. And so in case anyone else is in the same boat, I want to reassure you that there are so many mysteries left to investigate, and there are so many ways to do that. And so whether you want to build instruments, analyze data, build models, run experiments, there is space in the science of lunar volatiles for all these ways of doing science and for all of you. So pick your question, pick your method of choice, and I can't wait to hear what you find out. I majored in aerospace engineering with a focus on aerothermodynamics and fluid mechanics. And so it might seem like a strange career choice to spend most of my time studying worlds that have exceptionally thin atmospheres, but it does make sense, at least to me. Some of the most interesting atmospheres in the solar system are those that are barely there. What drew me to gas dynamics and thermodynamics was really just the things that molecules in motion could do. And to see what molecules in motion can do and how they can shape the worlds that they inhabit, all you have to do is look all around you across the entire solar system. You can characterize solar system atmospheres in terms of their mean free path, which is the average distance that two molecules travel before they collide. On our beautiful home planet, that distance is on the order of 100 nanometers. It's even smaller on Titan, which of course has a thicker atmosphere. And then we have Mars, Triton, coming back in a little bit to Io, Callisto, and then we have our moon, which is our closest example of the thinnest and most tenuous class of atmosphere in the solar system, which is the surface-bounded exosphere. But the really fascinating thing about the moon is that at various times in its past, it's traveled along this continuum. There were times in the past, there may have been times when the lunar atmosphere looked more like that of Io, Jupiter's volcanic moon. And so one of the science questions that's the closest to my heart and the one that I hope to be working on for several years to come is that of how the lunar atmosphere has changed over time and how that history is preserved. And critical to that is understanding how the contemporary lunar volatile cycle operates. Science to me is ultimately about storytelling, and it made me so happy to hear that message come across again and again in one of the sessions this morning. It's critically important that the stories we tell include everyone and speak to everyone. And I think we don't always do that. When we talk about space, when we talk about space exploration, sometimes the stories we tell about those things don't include everyone and they don't speak to everyone. We have to be better about that. Discovery and adventure don't always have to mean conquest and colonization. That's not a new idea. There are people among those that we share this planet with who have lessons learned over thousands of years in how to inhabit new worlds and live with them rather than subjugating the land, and in how to voyage in a way that respects relationships with the land, the sea, and each other rather than bringing oppression. There are communities that carry on those traditions. For example, the Polynesian Voyaging Society, from whose website I borrowed this photograph of a crew member on the Hokulea voyaging canoe, navigating by the light of the stars, which are still visible despite the bright quarter moon that you see here. It's also important to me personally to do my science with a sense of place. This concept of a sense of place refers to the intrinsic characteristics of a place, but also the meaning that people give to it. And it's a concept that brings with it a question, which is that of how do we choose to relate to worlds beyond our own? And this is something we're constantly doing as planetary scientists. We do a job in which we do a job that consists of building relationships with places, learning to understand their stories, sometimes visiting them. And I wanted to tell you a story of two unique microenvironments on two neighboring worlds, each of which has so-called resource potential, but also stories of their own to tell. The Serpentine Barrens are not too far from where I live in Maryland, on Piscataway and Susquehannock homelands. And they're called the barons because, of course, when the European colonialists arrived, they saw this land, they tried to grow timber in the soil, which is extraordinarily manganese rich. There's chromite ore, that's the resource. But they found that the timber wouldn't grow in that soil. And so they called this land a barren. But of course, if you look at it, you'll see that it is anything but barren. It is this incredibly rich grassland. And that strange singular soil means that you have wildflowers that grow nowhere else. And you have the entire ecosystem that sustains. It's an intensely alive environment. And I think another environment that is just as intensely alive, though in a very different way, is the microenvironment of the lunar poles. What gives this environment its life is the ebb and flow of shadows over that terrain that's soft and sharp at the same time, punctuated by the intermittent patter of micrometeoroids, and then in the shadows and in the sunlight, radiation and electricity build fairy castles out of dust. It's beautiful. And there is nowhere like this in the solar system. And so I think the lunar polar microenvironment, in fact, the lunar environment as a whole, has so much more meaning and so much more value, so much more worth than the value that it might have for commerce or for science. I think it's just as incredible and important a part of our collective heritage as anything we could put together with our minds or our hands. This is me in another place that's close to my heart. This is the beach near where I grew up. It's a vanishing beach as the sea levels rise, but it's a lovely one still. I grew up in Kerala, which is on the southwest tip of India, right here. I spent some of my childhood in England, came back to India for middle school and high school, went to Singapore for undergrad, traveled all the way to Texas for grad school, beautiful Texas, which is Austin, Texas, is the city that I've lived in for the longest. We moved around a lot when I was a kid, and that I can tell you firsthand that the stars at night really are big and bright in Texas. And then I came to Maryland, where I live and work now. And I've lived on Turtle Island long enough that I identify to some extent as Asian American. And I think what that means to me was best expressed by Professor Daryl Maeda, who pointed out that Asian American doesn't so much describe our personal identities or our family histories, in as much as it expresses an idea. And that idea is that as Asian Americans, we have to work together to fight for social justice and equality, not only for ourselves, but for all the people around us. That is what Asian American means to me. And I wanted to leave you with this. I love my job, I really do. I love sitting in front of my computer, writing code, writing words, even though I do that slowly, working with all the amazing people that I work with. But that is not my real job. My real job was expressed by the incomparable Professor Toni Morrison, who told us what she told her students, that when you get these jobs that you have been so brilliantly trained for, and all of us here have been brilliantly trained for our jobs, just remember that your real job is that if you are free, you need to free somebody else. If you have some power, then your job is to empower somebody else. That's the realest part of my job, and I hope to continue doing that and everything else to the best of my ability with all of you for as long as I possibly can. Thank you all so much for listening.
Thank you so much, Parvathy, for yet another incredibly inspiring talk. And per your last point, I wanted to note that Elizabeth Fisher put something in chat and said what a role model you have been to her. And you're making lunar science a fun and inspiring place. So you're doing exactly what Toni said. So already. So thank you so much for all you've done and all you're continuing to do. And it's just such a privilege to work together and to have you as part of SSERVI. So thank you.